Today we're going to decode the secret language of the world all around us. And that language is geometry. Believe it or not, it all starts with just two super simple ideas, lines and angles. These are the absolute basic alphabet you need to understand, well, everything, from a simple triangle to the most amazing buildings. So here's our game plan for today. We're going to start with the absolute basics, the building blocks. Then we'll see how those blocks create angles, and we'll learn how to classify them. After that, we'll dive into what happens when angles get together and pair up, and we'll finish with some really powerful rules that pop up whenever lines cross each other. So let's jump right in. All right, first up, the fundamental building blocks. You got to think of this like learning the notes before you can play a song. And it all begins with the simplest idea you can imagine, a line. So what exactly is a line? I mean, it seems obvious, right? But in the world of geometry, it has a very specific and pretty cool meaning. Okay, here's the big idea that makes a geometric line different from one you'd just draw on a piece of paper. Infinity. A true line has no start and no end. It's a perfectly straight path that just goes on forever in both directions. It has length, sure, but absolutely zero thickness. This breaks it down perfectly. A line segment is the piece you can actually measure. It has two clear endpoints. Think of it like the edge of a table. A ray is kind of like a beam from a flashlight. It has one starting point, but then it goes on forever in just one direction. And then you've got the line, which, as we just said, is infinite in both directions. It really all just comes down to the endpoints. You know, any 2 points are always collinear. Why? Because you can always draw a straight line between them. No big deal. The real question is, what about 3 or more points? If you can connect all of them with a single perfectly straight line, then they're collinear. If you can't, they're not. Simple as that. So we've got our building blocks. What happens when they actually meet? Well, they create angles, and that's the next critical piece of our geometry puzzle. An angle is really just the space that's created when two rays, we call them the arms, start from the exact same point. That point is called the vertex. The best way to think about it is like opening a pair of scissors. The little screw in the middle is the vertex, and the blades are the arms. The more you open them, the bigger the angle. Now, just like we classify different types of animals, we also classify angles, and we do it based on one simple thing, their size, which we measure in degrees. This table lays it all out for us. Acute angles are the little sharp ones, less than 90 degrees. A right angle is that perfect corner, exactly 90 degrees. Obtuse angles are wider, sitting between 90 and 180. A straight angle is exactly what it sounds like, a flat line, which is 180 degrees. And then the reflex angle is the big one on the outside, over 180. Okay, so individual angles are one thing, but things get really, really interesting when angles start interacting with each other. So let's check out some of the most important angle pairs. First on our list are complementary angles. A good way to remember this is to think corner. Two angles are complementary if when you stick them together, they form a perfect corner, a 90-degree right angle. So for example, a 40-degree angle and a 50-degree angle are complements of each other. Put them together and you get that perfect 90-degree corner. Next up, we have supplementary angles. For this one, think straight. These are two angles that, when you place them right next to each other, form a perfect straight line. And we already know a straight line is 180 degrees. So, a wide 110-degree angle and a 70-degree angle are supplementary. They fit together perfectly to make that straight line. So, here's the key difference, all on one slide. Complementary adds up to 90, supplementary adds up to 180. And here's a little trick to remember which is which. C comes before S in the alphabet, just like 90 comes before 180. Easy. Okay, now it's time to put it all together. By combining these ideas, we can unlock two of the most powerful and useful rules in all of geometry. These are rules that kick in anytime two lines cross each other. A linear pair, that's just a fancy name for two angles that are side by side and form a straight line. And as you can probably guess, this means they're always supplementary. They always add up to 180. And this brings us to a fundamental truth in geometry, an axiom. It's something we just accept as true. If you have angles that form a straight line, they must add up to 180 degrees. Period. This is a non-negotiable rule you can always, always count on. Now look at what happens when two straight lines cross all the way through each other. They form 4 different angles. The angles that are directly opposite each other, like they're mirror images across that intersection point, those are called vertically opposite angles. And this is the grand finale. It's a beautiful, simple, and incredibly important theorem. Vertically opposite angles are always equal, no exceptions. If one is 110 degrees, the one directly opposite it has to be 110 degrees. This one rule can solve a ton of geometry problems in a heartbeat. So, let's do a quick recap of our journey. We started with the basic parts, lines, rays, and segments. We saw how they form angles, which we then sorted by size. We learned that angle pairs can be complementary, adding up to 90, or supplementary, adding to 180. And finally, we uncovered that powerhouse rule. When lines intersect, the vertically opposite angles are always equal. So, now that you've got the language, here's the real question. How does this change the way you see the world? Just look around you right now. Look at the corner of your screen, the frame of a window, maybe the way 2 roads intersect outside. Can you see it? Can you spot the hidden geometry, the right angles, the linear pairs, and the vertically opposite angles that are giving structure to absolutely everything?